Prudent Scholars in association with Goa Headmasters Association.
I hope you were clear with yesterday's class. If you're not, then I would recommend that you watch the previous video so that you get a better understanding of what we're going to learn today. Today we're going to study a little in depth about trigonometry with regards to specific angles. Okay, now you remember that yesterday when we were discussing, we spoke about the trigonometric function and the related angle to it, right? But what we would do is we would just write it as sine A or cos B, cot C, and so on. But that C was some angle. Were we giving the value for that angle? No. But in today's class, or rather in your 10th standard curriculum, you need to know certain values which are related to a trigonometric function and the specific angle. So here I have a table which is empty right now, but I want to fill in information in that. So we are going to deal with angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So we are going to find out values, okay, for the trigonometric function of these angles only. Now can it be like I can have 31 degree and I want to find out the value of that trigonometric function for that angle? You can. If you use a scientific calculator, then you can find out, but in your class of 10th standard, you just have to worry about 0, 30, 45, 60, 90. That's it. Okay. Now, so no one is going to ask you this entire table, to write on a answer paper, but you are going to solve problems based on that. So we are going to spend a little bit of time in understanding how these values can be found out. First of all, you need to learn, to draw these two triangles. They're different. One is slightly smaller than the other. Okay. Then we are going to write 45 and 45 in both these places. Okay. Please learn how I'm, going about with that, because if you follow the same steps, you'll not make mistakes. So 45 and 45. Then what we are going to do is write 60 for the other triangle and base angle as 30. Wherever the angles are 45, exactly opposite to those angles, all we are going to do is write 1. Okay, and hypotenuse we are going to write 2. I hope this thing is clear. Two triangles, 45, 45, opposite to 45 is 1 and hypotenuse is 2. Same way for the other triangle, hypotenuse will write 2. The base angle was 30. So next to that, the side that is there will write 3 and the other side will write 1. Okay. I hope this is very clear. Once we are done with this, the bigger numbers, let's put a root sign. So in the first triangle, bigger number is 2, so I'll put a root sign for that. And in the second case, bigger number is 3, so I'll put a root sign for that as well. Okay. So two triangles, I hope you know how to write those values down. Then, this is our favorite table, what we have studied in the previous class. So here, sine is related to opposite and hypotenuse and so on, right? So if, say for example, I want to find out value of cos 30, because I've marked it in that orange color there. So cos 30. First of all, I need to know what does cos mean. So cos is adjacent upon hypotenuse. From where I'm looking at it, I'm looking from angle 30. So look at that triangle where 30 is marked. Okay. So cos 30 will be adjacent, that is root 3, and hypotenuse, which is 2. So my values 30, right? So marked over there, adjacent will be, and the value becomes root 3 upon 2. Do you think you have to literally study the table now? No, because if you know that part, of knowing the entire table of sine, cos, tan, cot, sec, cosec and the triangles exactly correctly, okay, exactly and correctly, you will be able to do this table done. So let's try another one. So here we are finding cot 45. First of all, we have to locate where is angle 45 and what is cot. So cot is nothing but adjacent upon opposite. So let us take mark one 45 angle. Now you will say there are two 45 degree angles. Which one should I consider? You can consider any one of them. It will not change the value. Okay. So cot 45 will be adjacent upon opposite. So from 45 when I look, adjacent is 1 and opposite is also 1. So 1 upon 1 will be 1. Okay, let's quickly try another one. Here I am finding sine 60. Locate where is angle 60 first, and sine is opposite upon hypotenuse. So from 60 when I look, opposite is root 3 and hypotenuse is 2. So this would become root 3 upon 2. Next, let us try as cosec 30. So first find out where is 30 degree. Cosec is hypotenuse upon opposite. So hypotenuse is 2, opposite is 1, so value will become 2. Okay. Now like this you can find out all the other values, so you can try a few. I am finding for tan 30. Can you look at the table and the triangle and think what could be the answer? First locate the 30 degree angle. Tan is nothing but opposite upon adjacent, so it would become tan 30. I marked it for you, 1 upon root 3. Did you think of that as the answer? Good enough, then you have already understood the entire method of going about with this. Let's try another one, sec 60. Okay, and by the way it is sec, okay, S-E-C, sec. So here 45, it will be hypotenuse upon adjacent, and that's how you get all the values. So I'll just quickly run through it, and like this when you do, one sec, okay. If you notice that in the first table you were able to get all the values. I know I've just rushed through it quickly. You can take a screenshot right now and then check for yourself, but you are able to find out values for 30, 45 and 60, but 0 and 90 is difficult to calculate. So because of that you will have to learn the next table, that is trigonometric table only for learning 0 and 90. It's simple. All you have to do is write sine, cos, tan, cot, sec, cosec, and 0, 1, 1, 0, 0, ND, ND 0, and ND 1, 1 ND. Now what is this ND represents is nothing but not defined. That means if you were to plot it on a graph, I'm going to teach you a simple dance step right now. Okay, so sine would be something like this, okay, cos will be something like this, tan, cot, and it becomes, if you do it a little faster, then it will become like a dance step. So are you going to draw them? No, you are going to do them in your, if you are going to take math in your 11th standard, then you have these things to draw on the graph paper, but basically that is how it will go. This is what you have to remember. Now I said tan is like this. This means that it is not going to touch any of the axes anywhere, and it goes straight up to a point infinity that is not defined. So we don't know. That's the reason we say ND are not defined over there. Please know these things, and if you completely understand, then you will be able to solve the next problem that we are going to see right away. So what kind of questions are asked? Questions are something like this. Evaluate 5 sine square 30 minus cos square 45 plus tan square 60. It looks a little bit complicated, but Trust me, I've taken the simplest problem first. Okay, all that we'll do is now we'll write brackets. Okay, so we have how many functions? 3, right? Sine is there, cos is there, tan is there. So 3 functions, so we'll write 3 brackets first. Okay, we'll write a little bigger bracket so it becomes easier to write the values. Then what we are going to look at is, they are separated by a sign, right? So sine square 30 is separated from cos square 45 with a negative sign. So let us put those signs over there. Then I will check for my trigonometric function, is there a square or a cube, whatever is the value, then I will write that also. So in this case, it is square, right? So I will write squares in all these places, wherever there is. Next, what I will do is, any number that is there multiplied with the trigonometric function, then I will write that also. So here it is 5. In the other 2 places, there is no number, right? So just leave it like that. Okay. After you have done this, then we go to our usual table and the 2 triangles. Simple, right? So when you're solving, look at that question. Okay, how many functions are there? Those many you will write brackets. Okay, 2-line brackets, big ones. Okay, then whichever sign is there, plus, minus, I will put it. Multiplication also can be there. Okay, I will write those. Then if it is raised to a square or a cube, I will write those outside the bracket. The numbers which are there multiplied with the trigonometric functions, I'll write those. And now we will write the values. So in the first case, forget about that square for a while. It is sine 30. First of all, what is sine? Sine is nothing but opposite upon hypotenuse. From where are we looking at? We are looking from angle 30, right? So looking at angle 30, okay, it would become opposite from sine 30, right? So opposite is 1, hypotenuse is 2. So the value of sine 30 is 1 upon 2, and that it is sine square, and I've already written the square, so there is no problem now. Next is cos square 45. Keep square for a while and then just find out the value of cos 45. Cos is nothing but adjacent upon hypotenuse, and we are looking from angle 45. So adjacent upon hypotenuse, when you do that, you will get 1 upon root 2. Square is already put, so no problem. Next we have tan 60. Tan is opposite upon adjacent. From which angle? 60. It will be root 3 upon 1. So in the previous part I was telling you, you don't need to actually study the entire table, is because of this. Imagine you are going to solve this problem, but you are spending another 10 minutes to write the entire table. How much time are you going to actually waste? So time is money, and time is marks over here. So don't waste them. And simple, right? So I've written all those values. If you do this correctly, technically you should get half mark for each of these, but depends on how the marking scheme goes. It changes. So once we are done with this, we are going to, in the next step, we are going to write those brackets once again. So let's do them again. Okay. And what we are going to do is write the signs, and we are going to square all whatever is there in the bracket. Wherever we have put a square, we will square that value. So 1 square will become 1, 2 square will become 4. So the value that I will write in the first bracket will be 1 upon 4. And I have already calculated that square, right? So I don't write that square once again. This 5 is outside, so I've written it 1 upon 4. In the second bracket, previous one it was 1 upon root 2. So squaring that, 1 square will become 1 upon root 2 square will become 2, because that root sign and the square sign will cancel off, and what we'll get is 2. So 1 upon 2. Okay. In the third bracket, it is root 3 upon 1 the whole square. So root and the square cancel, so I'll get 3, and 1 square will become 1. So 3 upon 1. I hope this part is clear till here. If you follow the exact same procedure, trust me, you'll not make mistakes. Then what we are going to do is, we are going to multiply the number, whatever is outside, multiply it only in the numerator, because it is just 5, right? So if it is written in the numerator, multiply it only with the numerator. Okay, so it would become 5 multiplied by 1 will become 5 upon 4 minus, there is nothing to multiply in the second bracket, so 1 upon 2 written as it is, plus nothing to multiply in the third bracket as well, so 3 upon 1. Now what we are going to do is, if you notice carefully, the denominators are all different. So I need to find out, or I need to make the denominators same. And how I do it is by using the LCM method. So take all those denominators and write it separately in the rough column. And all these things you have already studied in your 8th standard, 9th standard, and probably in this, even in the 7th standard. But still, if you can't remember, then check it out. Okay, so I will write all the numbers here. Then I will put a line like this, and then I think of a prime number, the smallest prime number. So we'll start with 2. Okay. Now my idea is to make all those numbers 1, 1, 1, which are presently as 4, 2, 1. So taking 2, which is my own thought number, I will multiply and I see whether I can get 4 as the answer. So 2 times 2 is 4, and 2 times 1 is 2, and 1 is written as it is. So the numbers which are green, written in green, are just telling you that I have multiplied so that I can get the top number as the answer. So it is possible. And if at all is the same, 1 means it is the end of it, so just get that 1 down, that's it. Now again think of another number which I can use to multiply and get 2 as my answer. So it can start with 2, right? So take 2, and 2 1 times is 2, 1 is already there, so just bring them down. Now my whatever I thought of creating is done, right? So the idea was to change that 4, 2, 1 to 1, 1, 1, which is done already. So this part is clear. Once I have done that, whatever number that I have, I was thinking of and used them there, those numbers need to be multiplied. So the ones which are in red especially. So 2 multiplied by 2 will become 4. Okay. So this 4 will become my new denominator. So I'll put one big upon sign and write 4. Okay, once I have done this, I will take all the fractions that I had got in the previous step, that is 5 upon 4, 1 upon 2 and 3 upon 1. Okay, I will write them in the rough column and multiply that number that I had just got, right? So 4 with all these fractions. So let's multiply. Now if you look over here, that 4 and 4 will get cancelled. What I will get is 5 in the first case. I have 1 upon 2 multiplied by 4. So 2 ones are 2, 2 2 are 4. So the next number that I can get is then 2 multiplied by 1 will become 2. In this case 1 and 4 I can cancel, so 3 times 4 will give me 12. I hope this thing is clear, because this is in the entire problem of this kind, all you have, students mostly make mistakes either substituting the trigonometric value incorrectly or finding, doing all this arithmetic incorrectly. So just learn this method and you'll be able to solve them, like a pro. So this, here what happens, so 5 minus 2 plus 12. So 12 chocolates you have, I take 2 from there, so I'll get 10, and 10 plus I give 5 more, so it will become 15, and upon 4 is as it is, so it will become 15 upon 4. So whatever the question was, that 5 sine square 30 minus cos square 45 plus 10 square 60, after solving, the answer that you will get is 15 upon 4. Okay, if you want to take a screenshot, you can, and then write it down later. Let us solve another one. Alright, so 9 cos square 60 plus root 2 sine 45 minus cot square 30. So what was the first step? First step was just to write the brackets. Here I have written. Next step is to put the signs. Okay. Wherever there is square or a cube, put that outside the bracket on top. So first one there is a square, second one nothing, third one there is a square, so I'll put that. Okay. Then I will write any number which is multiplied to that trigonometric function, we'll do that. Okay. And now we need our usual table and the two triangles. So what are we looking at? We are looking at cos 60 and from angle 60. So from angle 60 when I look, cos is nothing but adjacent upon hypotenuse. So adjacent will become 1, hypotenuse will become 2. So this would become 1 upon 2. Okay. Then sine 45. So look at the first triangle, whichever 45 you want. So 45 will be, sine is opposite upon hypotenuse. So from there opposite is 1, hypotenuse is root 2. So the value that comes in there will become 1 upon root 2. Next one is cot 30. So cot 30 will become, cot is what? It is nothing but adjacent upon opposite. So when I am looking from 30, adjacent is root 3 and opposite is 1. So it will become root 3 upon 1. Next step, all I have to do is square whatever is there. So when I do that, write the brackets, then write the signs and whatever is outside the bracket. So 1 square will become 1 upon 4. Okay. Here there is no square, right? So I'll write 1 upon root 2 as it is. Next one, there is a square. So root 3 square will become 3 and upon 1 will remain as it is. Now what I have to do is whatever is there outside the bracket, I will multiply. So 9 multiplied by 1 will become 9 upon 4. Root 2 multiplied by 1 will become root 2 upon root 2 and minus, or root 2 upon root 2 we can cancel it off and I'll write 1 upon 1. Now another small thing to keep in mind over here is that sometimes when these numbers are strategically put over there, you tend to cancel them off and even not write that fraction. That's the time you'll make a small error of calculating. So don't do that. Write that fraction as it is. Okay, even if it is 1 upon 1. And then here it will become 3 upon 1. Now here, are my denominators same? No, they are different, right? So all I will do is write them, okay, in the rough column, 4, 1 and 1, and then put lines like this. Think of a prime number, smallest prime number, start dividing and I will get, think of 2 times is 4 and then rest as 1 as it is. Think of another number and then I'm sure you're thinking of 2, right? So 2 once is 2 and rest all the numbers are same. Now once I've changed whatever I had written like 4, 1, 1, my idea was to convert them into 1, 1, 1, which are however many numbers you have, the idea is that. So once you have managed to do it, multiply the numbers that are outside. So the numbers that are in red, so 2 multiplied by 2 will become 4. Put a big upon sign, okay, and then write 4. Then what are we doing? We are writing all the fractions once again. 9 upon 4, 1 upon 1, 3 upon 1. And then what are we doing? Multiplying that new number, the denominator what we got, and multiply it with all the fractions. So doing that will become this. Once we have done this part, all I will do is cancel whatever I can. So 4 and 4 can be cancelled off, and in the first fraction I will get my answer to be 9. Second one, nothing can be cancelled. So 4 multiplied by 1 will become 4. Second one, 3 multiplied by 4 will become 12. Okay. Now, once you are done with this, I have plus 9 minus 12, and so do all the 9 plus 4 will become 13, 13 minus 12 will become 1 upon 4. So when you solve that entire question, 9 cos square 60 plus root 2 sine 45 minus cot square 30, substitute all the values, calculate, your answer that comes is 1 upon 4. You can copy the question and practice it out, and just to check the answer you can take a screenshot. Okay. Right. Next, let's go a little bit complicated one. I said complicated, not difficult. Okay. Here you have a question written in numerator upon denominator. Nothing changes, same procedure. Here we are going to see how many fractions are there. Let's take in the numerator first. How many? Cos, sec and tan. So 3 brackets in the numerator and 2 brackets in the denominator. So let's do that. A big upon sign and this. Then we are going to check for that trigonometric function is square there. So in the first case, yes. Second case, yeah. Third case also there's a square. So we'll put those squares. Everywhere there's a square, right? So let's write that. Signs and numbers outside which are there and all the squares. Now we need the usual table and the triangles. Okay. Now we are looking at cos 60. So look at the angle where 60 is there, and cos is nothing but adjacent upon hypotenuse. So adjacent is 1 and hypotenuse is 2. So it will become 1 upon 2. Same way, sec 30. Now sec 30 will be, I will look at where angle 30 is. Sec is nothing but hypotenuse upon adjacent. So hypotenuse is 2 and adjacent is root 3. So this would become 2 upon root 3. Next is tan 30. Tan is opposite upon adjacent. So 30, when I look from 30, opposite is 1, adjacent is root 3, so it will become 1 upon root 3. Same way, sine 30. Sine is opposite upon hypotenuse, and opposite is 1, hypotenuse is 2, so that would become 1 upon 2. Okay. Next is cos 30. Cos is adjacent upon hypotenuse, so adjacent is root 3, hypotenuse is 2. Okay. So I hope till here you are very clear with this. Next, what we are going to do is write the same brackets once again, and we are going to square those values. So let's put a big upon sign, all the brackets, signs and numbers which are outside, and then all we are going to do is just square whatever is inside the bracket. So 1 upon 2, the whole square will become 1 upon 4. 2 upon root 3, the whole square will become 4 upon 3. So whenever, think of it this way, whenever there is root sign, there is no, that root and the square will get cancelled and you will write the number as it is. Sometimes students make a mistake over here also. They will square and write 2 square as 4 and root 3 as 9. So don't do that mistake, keep that thing in mind. So this will become 4 upon 3. Next, 1 upon root 3 will become, can you guess? 1 upon 3, correct. And next is 1 upon 2, so it will become 1 upon 4, and root 3 upon 2 will become 3 upon 4. Okay. Once we are done with this, all I will do is whatever is outside the bracket we will multiply. So I'll just quickly we do it in that same step. So pay attention. So 5 multiplied by 1 will change this to 5 upon 4. Okay. 4 multiplied by 4 will become 16 upon 3, and as it now once I have multiplied, I don't require all those brackets, right? So let's remove them and let's take the entire problem on the next page now. So I've written the same numbers back again. are my denominators in the first section of that entire numerator, are they same? No. So all I will do is write them separately in the rough column. So the numbers will be 4, 3 and 3. The idea is to change these numbers into 1, 1, 1. So I'll start with 2 and I can cancel off 2 2s are 4. The rest of the numbers I can't divide with 2, right? So I'll just write it as it is. Next, think of another number, that is 2 again. So I'll first change that 2 to 1 and 3 will remain as it is. Now I have to think of another prime number with which 3 can be cancelled off, and so 3. So 1 will remain as it is and 3 1s are 3, 3 1s are 3. So now whatever numbers that I got in red outside, all I will do is multiply them, and that would become 3 times 2 is 6 and 6 times 2 becomes 12. So the number that I got now after multiplying is 12. Take that number and write it under one denominator. But this is the denominator of the numerator, entire combination itself, right? So we'll do that properly. So here, and then 12 will be written after the first line. Now if you look at the second case, in the denominators are same, right? So when the denominators are same, just write them 1. So there are only 2 fractions and both the places denominators are same. So I'll write it once. So this would become upon 4. Next what we are going to do is write the fractions. So 5 upon 4, 16 upon 3 and 1 upon 3. And multiply. What will you multiply? Will you multiply 12 or will you multiply 4? We have taken the fractions of which we have calculated the value as 12, right? So you multiply 12 to it. Okay, then 4 and 12 can be cancelled. So 4 1s are 4, 4 3s are 12. So this 3 and the 5 which is there multiplied will give me 15. Okay, in the second case 3 4s are 12. So 3 4 are, so 4 multiplied by 16 will give me 64. In same way, in the next case I can cancel off that 3 4s are 12 and 4 multiplied by 1 will give me 4. I hope this part is clear. Let us go to in the denominator now. When I have already written the denominator directly, because it is same, the numerators can be directly written. So 1 plus 3 and you are done with it. Okay, so keep that thing in mind. If at all my denominators in the second case also were different, then I would do the same step. Write all the denominators separately in the rough column, take some number of your own, do all this calculation, take all the fractions, multiply with that number that I have got, that is the LCM, and then calculate. The procedure remains the same. Now in this problem, my denominator was same, that was 4 in both the fractions, right? So I've written it directly, and whatever is in the numerator, I'll just write them down. So 1 plus 3, which would become, so calculating in that numerator, you get the answer to be 75 upon 12, and the second in the denominator itself, I'll get it 3 plus 1 is 4 and 4 upon 4. So that 4 upon 4 can be cancelled off, and once the denominator itself is not there, I will get something like this. I hope this part is clear, and the value will be 75 upon 12. Okay, so let us try solving another problem. Here we are told that it is not evaluate but prove. But what are we proving? Sine 30 plus sine 60 upon 1 upon sine 30 plus sine 60 is equal to what? It is equal to root 3 upon 3. Okay, so let us solve a problem where we are dealing with sine 30 plus sine 60 upon 1 plus sine 30 plus sine 60. Here we are supposed to equate it to something, because that's why it has said prove, right? So prove is nothing but root 3 upon 3. So what we'll do is we'll take that left hand side first and write it once again, and then start solving it. So again, first write the brackets for all the trigonometric functions that are there. So in this case, numerator has 2 brackets, so I have written that, and in the denominator again 2 functions, so 2 brackets. Write all the signs, the numbers that are multiplied with the function. Are there any? No, but there is one which is added, right? So I'll write 1 over there. Now we require, and you already know all this, right? So I will not take much time to telling you how the values work, because you already know how to calculate them. So sine 30 will become half, sine 60 will become root 3 upon 2, 1 will be written as it is, sine 30 is half, and sine 60 is root 3 upon 2. So once you are done with this, there is nothing to multiply, so I can remove all the brackets. Okay, and here my denominator in the first case are same, so I can write it directly once. So 2, and then I told you when the denominators are same, I can write the numerators directly. So this will be 1 plus root 3. Okay, in the denominator, now denominators are also same for 2 fractions, but the other one is just like that, right? So what I'm going to do is first write 2 in this case, and the answer will be 3. How is okay? That is because what I have done is look at only the first part, that is 1 plus, I'll tell you, okay, this. Now if you look at it as I have one number which doesn't have anything in the denominator, so we'll consider it has 1. Okay, and then we would calculate this as 1 plus 1 upon root 2. So where there is nothing, we write it upon 1. Okay, now I have 2 different denominators, so I will take them in the rough column, and it will be 1 upon 1 and 2. Take some number, divide it to make it 1 comma 1. So that's it, right? So 2. Once I do that, I will take both the fractions and multiply 2 to it. So 1 upon 1 multiplied by 2, 1 upon 2 multiplied by 2. So let's do that. And then I will get 2 multiplied by 1 is 2, and in the second case 2 and 2 will get cancelled. What I will get is 1. So I will get it as 3 upon 2. That is how I have written 3 in this step. So in this place over here, you get it as 3 is only because of this step. Okay, now a simple thing to remember, if you don't want to waste time and do all this calculation, then remember this as Langde ka Sahara. Okay, so what I mean by this is, now you see that 1 doesn't have a denominator, right? So all I will do is give it like a helping hand. So from here what I'm doing is, all I'm doing is taking this 2, multiplying over here as a support. So I know this doesn't make sense, but it will help you to remember. So 2 multiplied by 1 will be 2, and write the entire fraction as it is. So 2 multiplied by 1 will make it 2, plus 1 will be 3 upon 2. Okay, so that will be the answer over here. So instead of doing all these steps, I can directly understand from here it will become 3 upon 2. Okay, so just take the denominator, multiply over here, add it with this number, and write whatever is there in the denominator. So I have indirectly calculated the LCM, and everything is sorted over here. Okay, so based on that, I will get this as 3 upon 2. So imagine now 3 upon 2 plus root 3 upon 2, denominators are same, which I have written over here. So 3 plus root 3, that is how you get this answer. Okay, I hope this part is clear till here. And by the way, this is all what you have already learned in the past. Okay, this is not your 10th standard calculation that you are learning. So now here if you see that 2 which is there in the numerator section, okay, over there in the denominator, and the 2 which is there, both the yellow color ones, they're same, right? So I can cancel them off, and if I do that, this entire fraction will become 1 plus root 3 upon 3 plus root 3. So I'll write the entire thing back again over here. Now, but what were we asked to calculate? Something was given, right? Is equal to, you have to prove it. Is it this? No. Now in this case, we have to rationalize. What is the meaning of rationalize? Simple. Whatever is there in the denominator, multiply back again in the numerator and denominator. So this would become 3 root 3 upon 3 root 3. Now all that will change is, in the denominator, these two terms have a sign, right? So it is 3 plus root 3. Now when you are multiplying again, when you are rationalizing it, all you are doing is changing the sign. So 3 plus root 3 multiplying will become 3 minus root 3 upon 3 minus root 3. So the same things are written in the numerator and denominator, because I can just cancel them off and I will get to that same fraction once again, right? If I would just do it, multiply it in one place, then there's a problem. That's the reason we write it in the numerator and denominator. You have also learned how to rationalize in your previous classes. So this would become, now how did I get 9 minus 3? If you look at the denominator, it is nothing but a plus b, a minus b, right? Which is a square minus b square. So 3 square will become 9 and root 3 square will become 3. So that's how I get 9 minus 3. In the numerator, the entire thing needs to be multiplied. So 1 multiplied by 3 will become 3. 1 multiplied by root 3, so I'll just show you here. So 1 multiplied by 3 will become 3. 1 multiplied by minus root 3 will become minus root 3. Plus, okay, root 3 multiplied by 3 will become 3 root 3, and root 3 multiplied by root 3 will become minus 3. Okay. Now if you notice, there is positive 3 and there is negative 3. So they will automatically, they are same, so they will cancel off, and what I will get over here is minus root 3 plus 3 root 3 upon 9 minus 3. So this would become, so again, minus root 3 which is there, so it's like, 3 chocolates minus 1 chocolate taken. So this would become 2 chocolates, okay, upon 9 minus 3. So 9 minus 3 will become 6, and dividing this 2 and this 6 will give me root 3 upon 3. So 2 ones are 2 3s are, so root 3 upon 3, and that is what we were asked to calculate. So I hope this part is clear, and if you have understood it completely, then you can try solving this problem. So what are we solving over here? What are we proving? Now both the side, the right hand side is also a kind of a trigonometric function with some values. This side also is the same thing. So all I will do is write it as left hand side, substitute values, get an answer, stop over there, write right hand side, write that, calculate the value, and both those values should come same. So once you're done with that, then the problem is done. So left hand side is equal to right hand side, and you can solve this as well. I know they look very complicated, but if you follow the same step, put the bracket, square wherever it is there, signs, numbers which are outside, multiply them after substituting, all these things very carefully, then trust me, you will not make mistakes. Just a caution over there, it is multiplied, right? So just solve this entire part, okay, this entire part first, multiplied by this entire part. So all you have to do is calculate them separately, and last just multiply them and you're done. So these problems should be done on my channel, as I've already put these problems, so go ahead and check it out if you want to check the answers for these problems. And that's it for today's class. We'll continue in the next section. Thank you very much.